talked about them frequently in class. You've learned them in previous years, but we haven't really just written them down really clearly. So let's do that now. The main properties that we're going to talk about are the properties, the commutative properties of addition and multiplication, the associative properties of addition and multiplication, distributive properties, and then the identity properties. So let's start with commutative. Commutative. I always like thinking about the word. That's like commuting. When you commute to work. When you commute to work, you're moving. You're moving from one place to another. Commutative property of addition or multiplication is when you can just move things around. So, in addition, for example, if I have 3 plus 5, that's the same as 5 plus 3. That's the commutative property of addition. It doesn't matter what order I add things in. How about multiplication? 2 times 3 is the same as 3 times 2. Commutative property of multiplication. I can just multiply in any order I like. You'll notice that subtraction is missing because subtraction is not commutative. In other words, 3 minus 5 does not equal 5 minus 3. That's why there's no commutative property of subtraction. Same thing with division. 6 divided by 2 is not equal to 2 divided by 6. So there's no commutative property for division. But it does work for addition and for multiplication. Commutative, you're moving things around. So far, so good? All right, let's do associative property. When you associate with someone, you are in a group with them. When you get to work, your associates are the people who are in your group, who are in your, in your workplace. When you associate, you're in a group. So the associative property is when you're grouped together with people or things. In math, we use parentheses to group things. So the associative property of addition and multiplication says, I can use parentheses and group things in different ways, and it won't change the outcome. For example, if I have 2 plus 3 plus 4, I think you'll agree that that equals 2 plus 3 plus 4, right? Now, I can use parentheses to associate 2 plus 3, to group those together. Does that change anything? No. 2 plus 3 is 5, plus 4 is 9. How about if over here I feel like leaving poor little 2 out, but I want to group 3 and 4 together? Let's make sure I still get 9. 3 plus 4, that's 7, plus 2, hey, that's still 9. It doesn't make a difference if I'm adding, if I group things in different ways. The associative property tells me that I can do this and it's okay. That's for the addition. Should we try it with multiplication? Let's try 2 times 3 times 4. Let's see, 2 times 3 is 6, times 4 is 24. I'm just going to write it again over here. All right, let's group together 2 and 3. Let's see if I still get 24. 2 times 3 is 6. 6 times 4 is 24. Beautiful. But what if I do this? Will I still get 24? I hope. 3 times 4 is 12. Times 2 is 24. They both work. The associative property tells me that will always be the case. If I'm just adding, I can move parentheses and group things however I like. So too, if I'm just multiplying, I can move those parentheses around and group things however I like, and I'll still get the same result. That's the associative property. All right, distributive property you guys are all good at because we've been doing it all year. When you distribute, you're distributing things across addition or subtraction. The distributive property, goodness, property, helps us deal with situations when we are multiplying and adding or subtracting. It also helps with dividing and adding and subtracting. Here's an example. Now, if I had this, you know what I would do? I would just say, oh, let's do 2 plus 5. That's 7. That's 21. But the distributive property says, hey, if you want, you could say, that's 3 times 2, which is 6, plus 3 times 5, which is 15. What's 6 plus 15? Oh, that's also 21. So the distributive property says it's okay, it works, to distribute that 3 across the addition. You will get the same result as if you just added and then multiplied, for example. Now you might say, well, why do we need it? Why can't I just do 2 plus 5 and get 7 and get 21? Well, sometimes we have variables in there. So for example, if instead of having a 2 there, if I had an x, well, now I can't add x plus 5 because those aren't like terms. So to simplify that, the distributive property comes in very handy. And it says, oh, well, that's really just 3 times x plus 3 times 5. And of course, it could be subtraction if I wanted to. Let's say I had a 10 and a 5x minus 2, right? As long as I'm multiplying that 10 by that whole expression, I can distribute that 10. That's going to be 50x minus 20. And heck, I could have even more terms. Let's say I had a negative 2 times x squared plus 5x minus 7. The distributive property says, hey, this means I'm multiplying the negative 2 by each of those terms. Negative 2 times x squared would give me negative 2x squared. I might run out of room. I think I'm going to do it here. Negative 2x squared. Negative 2 times 5x would give me a negative 10x. Negative 2 times a negative 7 would give me a plus 14. So I distributed that negative 2. I used the distributive property. That one I think we're mostly comfortable with. The identity property is a little funny, but I think it makes sense once you think about it. Identity. When you look in the mirror, you see yourself. The identity property is when you do something to a number and you don't change its identity. Okay? So if I take a number 8, what can I add to that 8 and not change its identity? Yeah, sure, I can add a 0. And that does not change the 8 at all. 0 is called the identity element of addition. 0 is the identity element of addition because I can add 0 to anything, or even subtract it for that matter, and not change the number's identity. What do you think the additive identity of multiplication would be? What can I multiply by 8 so that I do not change its identity? 1. 8 times 1 is 8. 1 is the multiplicative. That's a fun word. Go ahead and say it. I know you want to. Is the multiplicative identity element. Or I can say it is the identity element of multiplication. I just like saying the word multiplicative. But maybe it makes more sense to say 1, I'm just going to write the number, 1 is the identity element of multiplication. Because I can multiply 1 times anything. Now you might be saying, well, duh, but actually this is incredibly important. I multiply things by 1 all the time. If I want to add fractions, for example, and get a common denominator, I multiply by a fancy form of 1. Right? 3 over 3 is 1. 2 over 2 is 1. That's what allows me to add fractions, is this identity property. So it actually is a pretty powerful property when you think about it. Okay? How are we feeling? There are certainly more properties, but that's a good start for now. Come and ask me if you have any questions.
Tell you something about my